So in this last video we will draw some conclusions about the course on experimental design, and the first conclusion is that the uh, main factor or the main driver to choose one experiment or the other is the number of factors that you have. If you have a low number of factors, then this completely randomized design or block designs with randomized, they are good if you want to compare carefully what are the differences between groups, and if your main objective is to identify the factors that are making a difference. This full factorial if you have a low number of factors, or fractional factorials if you have a large number of factors, would be fine. And if you have continuous variables, then you should use one of these response surface designs that we have seen. And another way to choose the experiment design would be these kind of guides, and here I'm giving you one example. It is not necessarily the only one, so it depends on what is your goal of the experiment. So you want to do a regression, so that means continuous variables, or you have discrete factors, so that would be kind of an ANOVA-like design. Then how many do you have blocks? Do you have can you block hold all the treatments or not? And then you will have incomplete designs or complete designs, and so on. And we have seen all these ideas along the course. And regarding the incomplete designs and the fractional designs, we have seen that the number of executions are different depending on the design. So here we have seen a few of them. We haven't seen, for instance, Taguchi designs, but the idea is that depending on the number of factors that you have, the number of executions, if you want to do a full factorial, can grow very quickly, and then you need to do a fraction only. The fraction will allow you to estimate the main effects and the second order or third order effects, depending on what is your confounding pattern. And we have explored all these things of resolution and this thing. Yeah, this is just a kind of summary of the number of executions for each one of the different designs. And in general, what we can say is that you should define the objectives of your experiment. I want to do an experiment to measure this. You should identify all sources of variation, and some of them will be coming from the treatment factors, that are the ones that you are really interested in and their interactions. Some of them will be coming from the experimental units, these are the residuals, and some others will be coming from other variables you are not interested in but you have identified, so blocks, kind of noise factor, covariates, and you should put all of them into your analysis equation, because the treatments will be compared to the residuals, and all the variance caused by these other factors that you have not explained will go into the residuals, and then this comparison may not turn significant, simply because you have too much variability and unexplained variability. And choose an appropriate rule for assigning experimental units to the treatments, and remind always to have blocks, to have replicates, to keep orthogonality if you can, and always to randomize, to unblinding, to prevent you from having bias. Before doing the experiment, you should specify which kind of measurements will be made. You have run a pilot study if possible and needed, not all the experiments need a pilot study. So only those in which you are not sure about, mostly about the logistics, because about the statistics, we saw at the beginning that the pilot studies, they have very few samples, and then they imply a lot of uncertainty. You should specify the model before doing the experiment, because otherwise, if you do it after doing the experiment, you are doing data snooping. You should outline the analysis, and you should calculate the number of observations that need to be taken. And experiment design, I, I like uh, to compare it to this thing, to this example. So if you do all these things wrong, not completely wrong, but probably it is not terrible, you could have done better. So for instance, if you want to wash your baby, it is better to do it like this than to do it like this. So probably you are badly treating your experiment, but it will not die. So it dies if you don't compute the sample size correctly, and then that's why researchers are very much aware of the sample size calculation, but they're not so much aware of the experimental design. So all these ideas of blocking, orthogonality, replicating, randomizing, and blinding, they're aware, but yeah, the others are not so much, and all these possibilities of factorial designs, fractional designs. So you could have done better. You don't need to do all combinations of all factors if you want. If you do them, okay, it is not the best thing you could have done, especially because the number of samples that you will need, because the number of combinations can be high, can easily go very quickly to very large numbers. So you could have done better, but it will not die from that. But if you fail to compute the sample size, the experiment will die. So I hope that you have enjoyed this course, and this would be all for it.